We want to solve quadratic functions by graphing and factoring. And in this case, we want to solve quadratic equations algebraically by factoring. Problem 5. You are designing a garden for the grounds of your high school. You want the garden to be made up of a rectangular flower bed surrounded by a border of uniform width to be covered with decorative stones. You have decided that the flower bed will be 22 feet by 15 feet, and your budget will allow for enough stone to cover 120 square feet. What should be the width of the border? So the first thing is we have to get an idea of what this looks like. And so I'm going to just do a sketch. And so we got some borders. And the border in this case is 15 by 22. So that's the actual garden. But then there's a border of uniform width that goes around. So whatever the width is all the way around, it should be the same. And although this may not be exactly the same because it's just a sketch, this just gives us an idea of what the dimensions are going to be. So we don't know what the width is, but we know that it's uniform. So all the way around, the width of this is going to be x. So the dimensions from this corner right here to this corner right here, that's going to be x plus 22 plus x. Or 22 plus 2x. And the dimension from here, I'll put it on the side, from this corner to this corner is going to be x plus 15 plus x. Or we can write it down as 15 plus 2x. So those are the total, that's the total area of this space here. Then we got to remember the equation for area. So we have area equals length times width. And now we can start substituting some things in. So the area, total area, and we're talking about area of the decorative stone. So the total area of the decorative stone is 120 square feet. So that's how much we can afford, 120 square feet. And that is going to be equal to the length, which in this case, the length is equal to 22 plus 2x. And the width is going to be 15 plus 2x. Now, here's the issue is, that is not the equation that we're looking for, because that's the equation of this entire area. But the equation that we're looking for just represents the decorative stone, which is going to be the border around the garden and not including the garden. So we have to take that garden out, or take the donut hole out, and that is 22 by 15. So we're going to have to subtract the area of the garden, which is 22 by 15. So now we just have, we have to just distribute these and figure out what we get. So we can write down 120. That's not going to change right now. 22 times 15, that is 330. And 22 times 2x is 44x. And 2x times 15 is 30x. And 2x times 2x is 4x squared. Then we have 22 times 15, which we already did, which is negative 330. And then we should be able to cancel some things out. So the negative 330 and the positive 330 cancel each other out. And then we can say 4x plus 30x, that's equal to 74x. We always like to write our equation or quadratic equation with the lead term in front. So that's positive 4x squared. So we're going to write that out front, 4x squared. And that is equal to 120. So we've accounted for all the terms. And now we know that this is a quadratic equation because we have the x squared term there. So we want to get 0 on one side. So I can subtract 120. And then we get 0 equals 4x squared plus 74x minus 120. So now we have it to the point where we can look to factor it. And all of these are even, so we know we can take a 2 out. So we can say 0 is equal to 2 times 2x squared plus 37x minus 60. And then we can look to factor it. And we get 0 is equal to 2 and we can put, we know that 2x times x is 2x squared, and two numbers that multiply to negative 60. We can say negative 3 and positive 20. Now we can use the zero product property because we have two factors there, and we can use the zero product property. And we can say 2x minus 3 equals 0. So we add 3 and add 3, and then we get 2x equals 3, divide by 2, and then we get x equals 3 over 2. So that's one possible solution. And then we have to do the next one, which is x plus 20. So we can say x plus 20 equals 0, and we can subtract 20. And then we get x equals negative 20. And then we can look at our two answers. So we have 3/2, negative 20. So this one can't be a negative width. Cannot have a negative width. So this cannot be the answer. So the width has to be 1.5 feet. So we said x was equal to 3.5. 3 divided by 2 is 1.5 feet. So that is our width.